Hello everyone. Today we're going to start looking at another type of factoring situation that can occur, and that is when you have trinomials, but trinomials that you have to common factor before you do anything else. So if a trinomial's first coefficient isn't 1, you must see if you can common factor before doing anything else. We call these types of trinomials type 2 trinomials, and there are a couple of different types. We're only going to be seeing the first type. And here's an example. If I asked you to factor the following, what would you do? The first thing you would look at is see if it has a 1 as its first coefficient. And as you can see, it does not. That's a problem. That makes this a type 2 trinomial. However, can we divide out the 3 from all 3 terms? Well, since 21 is 3 times 7, and 36 is 3 times 12, we have a greatest common factor of 3 in all 3 of those terms. And when you have a greatest common factor, you can pull that greatest common factor in front and put the leftovers inside the bracket. So what would be our leftovers here? There is no common letter because there's no x in this last term here. So you cannot pull a letter out in front in this case, only the 3. So the leftover would be 1x squared, 7x, and 12. And then you'd have to ask yourself, what are the signs? Well, we did factor a positive value out, so that means none of the signs change between the terms. And now we have a factor in front and a trinomial inside, and this has now a 1 coefficient hiding here. And those are the same types of trinomials that we've recently seen in a previous video. To factor those types of trinomials, we take the last number, 12, we put it at the top of our tree. We take the middle number, 7, put it at the end of the tree, and go about asking the question, what 2 numbers multiply to 12 but add to 7? And that would be 4 and 3. So watch what happens here. The 3 just tags along for the ride, but our trinomial now breaks down into the 2 brackets that we're used to seeing. We will write x plus 4 and x plus 3 in those 2 brackets. Those 2 numbers came from these 2 numbers right here. So that's what the tree is useful for. So the only thing that's new in this type of factoring, once again, if you don't have a 1 as your first coefficient, you sometimes are going to be able to common factor that coefficient out of all 3 terms, and then the rest of the 3 terms become a regular trinomial. If you cannot common factor that 3, there's a whole other way of factoring that we actually don't see this year. Let's look at the next example. So once again, this trinomial does not have a 1 in front. We're still being asked to factor it. Therefore, we have to see, can we common factor it out of all 3 terms? Well, as you can see, all 3 of them are divisible by 2. This is 2 times 1, this is 2 times 1, and this is 2 times 6. So there is a greatest common factor of 2 here. So we're going to pull that greatest common factor out in front. No x's are common, so we can't take the x's out. And what are going to be our 3 leftovers? Well, we've got 1x squared. There's our 1 that we're looking for. We have 1x, and we have 6. And then we look at whether or not we factored out a negative number. We did not. Therefore, our signs between the terms stay the same. It'll be a plus between the first 2 terms and a minus between the last 2 terms. And now we're back to having our type 1 trinomial here. So we're going to take our negative 6 as the top of the tree. I'm not going to use colors anymore. We're going to take our positive 1 at the end of the tree, and we're going to go through the factors of 6 that potentially could add to positive 1? Well, that would be 3 and 2, but one of them has to be negative to add to positive 1. The 2 has to be negative. 3 times negative 2 is negative 6 when you multiply them. 3 plus negative 2 is positive 1 when you add them. And once again, our brackets will now break down into 2 more brackets. And we put the x plus 3 in the first one, the x minus 2 in the second one. It does not matter what order these go in, by the way. If another student had written minus 2 and plus 3, that's fine. I just personally like to always put the bigger number first. And that would be your solution to that factoring scenario. Another example. Now in this case, there's a lot more negatives, and I wanted to show an example of what happens if your coefficient not only is not 1, but is also a negative number. We've already seen examples of this in previous videos. As soon as your first term is negative, you do want to factor out the negative sign as well as whatever number you're going to choose. Now, can you see what number all 3 of those are divisible by? I'm hoping you can see that 7 is 7 times 1, 21 is 7 times 3, and 14 is 7 times 2. But we're actually going to be factoring a negative 7 out of all 3. So what's that going to do? Well, if I factor out that negative 7 out in front of my bracket, what are my leftovers? 1 times negative 7 is negative 7, so it'll be a 1x squared. There's our 1 again. 3 times negative 7 is negative 21, but that's a positive 3. So now the sign in front of the x term has changed. It was a minus in front of the 21 in the middle term. Now it's a plus because we factored out that negative sign. And then negative 7 times positive 2 is negative 14. So this becomes a positive 2. Once again, the sign has changed from what it was before. Then we set up our tree. 2 goes at the top of the tree. 3 goes at the end of the tree. The 2 numbers that multiply to 2 and add to 3 would be plus 2 and plus 1. Therefore, our trinomial bracket becomes our 2 brackets, putting in x plus 2 and x plus 1 as our final answer for our fully factored trinomial. Just a quick reminder, if you have 2 terms, this is where we used to see common factoring. If you have 2 terms, you always want to check to see if you can common factor, but you cannot trinomial factor because it's not a trinomial. What can we take out of both of those? Both of them have a 4 hiding in it. So I will take that 4 out. Both of them also have an x hiding in them. I will take 1x out. And then I ask myself, 4x squared divided by 4x gives what? And that would be x. Negative 8x divided by 4x gives me negative 2. So look at the difference between these 2 answers. Notice how this one has 2 brackets, this one only has 1. That's because it's a binom or 2-term expression being factored, and it's being common factored specifically. Whereas when you have a trinomial being factored, you're usually going to end up with these 2 brackets if it's factorable. So you cannot forget all of the past types of factoring we've seen. As another example, we're going to do a difference of squares here just so you remember what they look like. Now, difference of squares is a special kind of trinomial factoring where the middle term is 0. But if you notice that it's a difference of terms, you just open up the 2 brackets, you get x plus 8 and x minus 8 because both of them are square rootable, and the square root of 64 is 8. So you put a plus 8 in the first one and a minus 8 in the second one. So right here, you've basically got an example of all of the different types of factoring that you can run into in grade 11 math. So that's the end of today's lessons. Not a very long one. There will be some homework, so expect some work, and we will talk to you soon.